Welcome back to the Critical Power channel. We're here on this special backup and generation flagship broadcast. My name is Tam Pledger. I'm a channel manager here at DCD. And today we will be discussing modern UPS, how to design a power efficient facility. And who better to discuss this topic than the Legrand team that I have here on the call with me. I am joined in the studio by David Press, UPS Center of Excellence, Northern Europe BDM at Legrand. Hi, David. I'm also joined by Pierre, Ecuyer, Director for the Center of Intelligence, again at Legrand. Pierre, apologies, I've probably butchered your name there. Very sorry.
Perfect.
Before we get into the context and the topic, let's start off with a very quick round of intros for the audience members that may be less familiar with you both. Dave, I'm going to come to you for this one. Can you kick us off with a little bit about yourself, your journey in Legrand, and what you're working on currently?
Yeah, so as I say, I'm Dave Press, BDM for Northern Europe on the UPS Center of Excellence. Effectively, I deal with everything in the way of influencing specification, dealing with customers, etc. In the market of UPS, and yeah, that's pretty much me. Thank you.
Short and sweet. Thanks, Dave. Pierre, quick intro from yourself.
Sure, my pleasure. So Pierre Ecuyer, I'm leading the Center of Excellence for Legrand for critical power, looking after UPS, transformers, high-power busbar, and services. And basically, my background is pretty much in the data center industry for the last 20 years, looking about services, sales, and operations.
Fantastic. Thanks, both. I mean, on this call alone, you've both got, a conjoined 50 years of industry knowledge within the data center industry. I think it's a really interesting topic and one we have talked on Legrand. So I'm interested in seeing how this has evolved over the years. We'll be discussing a bit more on AI, HPC, how that's pushing power, and we'll focus in on where UPS really earns its keep. So we're talking on keeping losses low at high density, balancing that CapEx and that OpEx for long-term efficiency, and why footprint maybe isn't everything, touching on serviceability and TCO, also modular and containerized builds. So I think the goal for this conversation is pretty clear. We want those practical takeaways that operators can apply after this. So let's start off with looking more in depth at the role of UPS in meeting higher power and the role that takes within efficiency. Dave, maybe I'll come to you for talking point one. With these high power requirements and those dynamic load profiles that we're seeing across the market, what role does UPS play in supporting the rise of high density, high power facilities that we're seeing?
Right, so obviously UPS is there as part of a critical power system. It's there to support the loads that sit on the tail end of it. What we're seeing now, though, is that there is a massive rise in the power consumption and the power rating of racks and servers. This has been driven by AI, it's been driven by high power computing. But what it effectively means is that the UPS is becoming more critical with respect to efficiency. We're seeing spiraling costs of energy at the moment. And so every percentage point of saving that you can get within your critical power system is obviously going to pay huge dividends when you're looking at revenue for a colo, etc., and even margins for a hyperscaler. So the UPS is now playing a much bigger role within those efficiencies. Previous technologies, with the likes of IGBTs, etc., have really topped out around the maybe 97% mark for efficiencies. And prior to that, we were looking at transformer systems. Now with silicon carbide technology, we're actually seeing that we can get much higher efficiencies. And in the case of our latest solution, we're up at 98% plus, and that's in a VFI mode as well. So again, if you look at that 1% efficiency, it basically turns around and takes a 10-year return on investment down to 5. So, it's a huge, huge, huge saving that we're seeing.
Fantastic. And thank you for that intro. I think it's important just to put more context on what we mean by efficiency. Before we go chasing things like footprint and talking about that, can you just explain in more detail where efficiency actually lives across that load curve and go into a bit more detail for people less familiar with the topic?
Absolutely, yeah. I mean, traditionally, the load curve has had one particular profile, which with silicon carbide has now changed. So what we're seeing is that maximum efficiencies are actually at much lower loads. So typically 25% would be the highest efficiency of a UPS now, tailing off slightly to 50% and tailing off more to 100%. But when we talk about 100% loading on a UPS, specifically ours, we're still talking 97% plus efficiency. So, it's even at 100% loading, we're still talking the highest loading of the previous generation, or highest efficiency, I should say. Now, the silicon carbide technology is there. Everybody's utilizing it. However, they're utilizing it in slightly different ways. So if you look at the characteristics of silicon carbide, effectively, you can make things really, really small, or you can make things really, really efficient. There is a balance act somewhere in the middle where you want to find the correct size via the correct efficiency. So it's, we're in a strange world at the moment where AI and HPC are coming in. Nobody knows really what's going to be happening over the next 5 years. All we know is that loads are going to increase. So, and when you're talking increased loads and you're talking spiraling costs of energy, efficiency now becomes such a massive, massive driver, where previously it maybe hasn't been so much of a big deal.
Yeah, I mean, you really hit the nail on the head there with why it's such an important conversation. With the evolution that we're seeing grey space expansion, minimizing power loss is something that I'm having more and more of conversations across on this channel. I want to dig into the size versus efficiency because I know a lot of people watching this will have questions on that. Can you explain, please, why footprint isn't everything? Why right sizing and those modular scaling beats chasing that smaller footprint? Can you go into that in a bit more detail?
Absolutely, yeah. I mean, previously UPSs used to be massive. It was as simple as that. With transformer technology, you had a transformer built into the UPS itself. With IGBT technology, again, you had to dissipate a lot of heat. Therefore, they were much larger. With silicon carbide, they're actually far, far better performing. And therefore, you can reduce the size of a UPS. So when I say they're better performing, they've got much, they can operate at much higher temperatures, for one. They've got much higher efficiency within the actual component itself. So what that enables people to do is to reduce the size of a UPS. Now, this is great news if you're trying to containerize or put UPS into an EPOD, because the smaller you can make it, the more you can fit into an EPOD, and the easier it is. However, if you make things very, very small, the laws of physics, you just can't dissipate the heat. Even though there's less heat to dissipate, you still need to get rid of heat. And so therefore, if you make a UPS particularly small, then you're not able to take the full advantage of the efficiency gains you're going to get with the silicon carbide MOSFETs. In addition to that, there are some problems that you may get with the installation, i.e. trying to take bus bars in and out. If you've got a really, really small UPS, it's very, very difficult to fit bus bar flanges in there effectively. So you have to try and find a balance where the product is small enough to containerize and yet big enough that you get the advantages of A, installation, and B, efficiency. Okay, there are other advantages, which I'm sure we'll touch on later. But fundamentally, that is the balancing act that everybody's sitting at the moment. It's just trying to find something small enough to fit in an ePod, but with a maximum efficiency, because we have to look at, operational expenditure as well as CapEx.
Yeah, as you were saying, we're into an unknown region here within the industry. That balancing act, is that something that you're seeing as a misconception with the people that you're talking to? Is this a common misconception that people are having?
Yes, there's loads of people, and it's all like, we need the smallest UPS possible. And that is fantastic if you're going to try and build an ePod the size of a matchbox. But ePods aren't that small. We've got switchgear in there. We've got transformers in there. We've got all the cable containment in there. We've got busbar in there. We've then got all the ancillary systems that sit around it in the way of fire detection and extinguishing. These are relatively large modular build products. Providing you can fit a UPS into that with everything else, then that is really where you need to be. It doesn't need to be any smaller than that. And there are additional advantages where, maybe utilizing busbar and not having to put any additional boxes in there and just being able to flange directly onto the product will again save some more space. So we don't need to chase for the smallest product ever. What we do need to do, though, is find that fine balance between the size and the efficiency.
Thank you.
I think one misconception is most probably due to the way we measure efficiency. Basically, we measure it in savings in watts, and it goes way beyond. It goes by all the capacity you can unlock with the relevant efficiency for your usage, the savings on the cooling, and the scalability. Because as mentioned by Dave, if you have a very small UPS, but then you need some adaptation boxes for the flanges to make safe connections, you're not saving anything. You're making your life more difficult and take more room in the ePod if you go containerized. So it's really a balance that needs to be found between all the different elements.
That's a really interesting point. Yeah, and for people that have expressed those concerns around efficiency, are you seeing any other maybe misconceptions or anything in the industry that you'd like to address?
There seems to be a lot of ambiguity about products in the market, about the size of products, efficiencies, things like clearances. They're very, very small clearances, but if you have a product that requires a 200 mil clearance at the back, be something that requires no clearance at the back, then, the UPS size isn't necessarily relevant. It's the clearance sizes. So you kind of have to look at the UPS as a total, including clearances, including flanges, including everything else for installation, rather than just looking at the box and specifying that.
That's very interesting. Yeah, there seems to be quite a lot of misconceptions that we can address here on UPS. I'm wary of time, so I'm not going to ask too many more questions on that. I think it's important to touch on kind of designing for long-term efficiencies and what that actually means as well. We mentioned before, energy costs are spiraling. We're seeing more carbon emissions. How should operators weigh those CapEx savings against the OpEx benefits that we're talking about when investing in UPS systems? Pierre, maybe I can pull you in to answer this one.
Sure. So I think when we talk about efficiency and long-term efficiency, so that's a long game. So it's how you will be able to manage the CapEx versus the future OpEx spendings over the years. But more than the OpEx, it's also the maintenance cost, the maintainability, and basically all your sustainability metrics that, as Dave mentioned, we face big demand in terms of power these days. So sustainability seems to be a bit less relevant in the decision made, but we'll have to cope with these in the next 10 to 15 years. while the current data centers will be in operation. So basically, you need to look beyond the price of the product, anticipate its future costs, which is something the vendors should openly talk about it, should provide evidence, and it goes beyond the pure efficiency of the product itself. It's the maintenance cost being driven by the conception of the product and the frequency of replacement for components, wearing parts, etc., etc. So all of this has to be factored in the decision that is made at the CapEx, so at the investment time. So you know roughly what will be your total cost of ownership for the next 10, 15, or 20 years. And for example, one big hurdle for customers is to decide whether they want to calculate their total cost of ownership for 10 years, 15, or 20, because it's a different game.
So by that metric, then, are you saying that serviceability is one of the most overlooked efficiency levers? But when talking about TCO, or is it something else?
No, definitely serviceability is something difficult to address through simple metrics. You need to go really beyond the specification of the product, engage with the vendor, discuss with them, understand what it really means, but it can really make a difference. It can make a difference when you operate your data centers. If you need to stop some UPSs for 2 days every 3 years, it will have a big impact on your operation, whereas some others will offer you to do some big maintenance work only once every 5, 6, 7, or even 8 years. What we're aiming at. So really, serviceability is driving cost and is driving risk as well. So this is something important. We see customers looking after this kind of information, but it's difficult to grab and put a KPI on that. So that's what it makes. It makes it very difficult to really balance between the CapEx, the OpEx, and this new aspect of things.
Yeah, and if I can ask as well, when we're talking about design, what about the customers that have maybe remote builds and remote maintenance needs? How does that link into UPS and serviceability and some of the things that we're talking about?
So, yeah, I mean, remote location, they face many challenges, many logistics. So, I mean, they can be affected by the weather, difficulty to access them, and I think the lack of experience and skilled people to operate on site. So basically, what customers who operate remotely, I mean, on remote location, I think about Iceland, for example, the north of Norway, or a location where it's sometimes difficult to reach and just to send spare parts. So they want things that are able to maintain the cell alone. So basically, in regards to this remote location, I mean, the approach is really about first equipping customers to make the right decision, and that's training the people. People need to know what they operate. They need to be comfortable with it. They need to be able to troubleshoot and make the right decision. The second thing is we also need UPSs and systems which are easier to operate. So what we're doing at the moment is working with algorithms that are embedded in our product. So we can help people troubleshoot and guide our customers for the reparation or the replacement of components. So that's a big axis we're working on. And finally, and it lies with the design of the product, is how can we design the product with a minimum number of components and spare parts to be stocked on site. So that's why also we go modular. We go modular for the power modules, like everybody does for, I would say now, a decade. But we also go modular for some other features in the UPS, like the static bypass, which has taken the same approach. it really enables to limit the number of spare parts, different spare parts, to keep on stock. And it really facilitates the replacement because you replace a full module and buy a new one. You avoid to enter into the electronics and change the settings of the whole UPS.
Thank you. You've brushed on a point that I wanted to bring up. I think it's really important that we talk about modular and containerized solutions. Dave, maybe you can follow on from that with a little bit more of when is a containerized UPS solution the right answer? And maybe for those looking at it, when is it not the right answer?
Yeah, there's a bit of a bow wave at the moment for offsite build. And there are definitely benefits because speed of deployment is massive. So if you're looking at a colo as an example that's trying to expand quickly, then containerized builds are particularly useful because it becomes a cookie cutter design. So you just literally deploy more containers, whether they be 1, 2, 3, 4 megawatt, and effectively you just ship them to site and plug them in. But that doesn't meet every requirement because there are shipping issues. Containers have to be moved invariably on the back of lorries. So where you have very remote locations, potentially it's difficult to move containers there. The other thing as well is if you're looking at a hyperscaler build, then they're not really looking for very fast expansion. They're going to build a site at 100 megawatts and that will be the site. So therefore the additional cost of offsite build really isn't any major benefit to them. So it's completely dependent. There is a place for both. At the moment, though, it looks like the market is looking at containerized builds much as the fidget spinner. Everybody has to have one. Everybody needs it. And actually, there's no requirement for everybody to have it. It does add additional cost, but then it saves costs in the in the actual build. So again, you have to look at every application and work out what the actual requirements are, rather than just say we want a containerized solution.
Yeah, I love the fidget spinner analogy there. As you say, I mean, more and more people are now looking to this. Is it changing the way that data center solutions are being deployed and how we're seeing UPS being deployed?
In some aspects, yes. In some, no. Because fundamentally, a UPS is delivered to site. It's installed, batteries are connected, there's an SAT. Whether that is actually at a customer's site or whether that's at a container builder doesn't really matter. What does matter, though, is things like fault currents. Fault currents, when you're looking at a containerized solution, you have very, very, very little impedance in the system because they are so compact. And that means you could end up with absolutely ludicrous fault currents. Whereas historically, if you're looking at a traditional build, there's more copper in there. Therefore, there's more impedance in there. Your fault current drops. So you do have to be really, really careful about the benefits and the disadvantages. It's look at every application as an individual application and work out if the benefits outweigh the disadvantages.
Okay, so really it's a site-by-site situation on using this. Is that right?
I would, in my opinion, absolutely 100%. It's if the drivers are there to use a containerized solution, then absolutely 100%. But don't do a containerized solution just because everybody else is.
Okay, so peer pressure aside, I'm interested, what does containerized solutions and standardized solutions, what does that mean further up for things like the supply chain? Is it changing how customers behave, how we're seeing projects grow?
We're seeing that deliveries are being driven down. It's all about speed of deployment. So where you probably had some degree of leeway within the supply chain previously, now it's almost becoming a just-in-time manufacturing process. So everything has to be there at exactly the right time to fit into the container, the E-pod, the skid, whatever that may be. And that's putting pressure onto manufacturers. It also means that if there's anything outside of a manufacturer's control, it puts the project at major risk. So if there's any shipping issues, as we saw with the Suez Canal, as we see with the Houthi rebels, there's a lot of risk at bringing stuff from around the world on a just-in-time basis. From our point of view, it's actually not such a big risk because we manufacture in Europe. So having a European manufactured product with European manufactured sub-assemblies means that you're actually getting a much, much lower risk on manufacturing and deliveries. It also helps with our CSR footprint as well. So, and carbon footprint. So yeah, again, there's lots of different factors to take into account.
It's interesting that we're seeing this knock-on effect further up, risk being everyone's least favorite word across the industry. Do you see kind of off-site containerized builds and those sort of solutions as a long-term efficiency solution, or is this more of a short-term fix?
I think it's a short-term fix for deployment. It will probably carry on. And the market statistics are showing that it's growing. So it's one of these things where, off-site build is actually, perceived as a benefit in many, many cases. And I can't necessarily see any downturn in that. So I think it's long-term, but from an efficiency point of view, again, we're back to that balance of making stuff small enough to deploy in an E-pod, but large enough that we're going to get good efficiencies. And this is going to become more of an issue with AI because the load profiles are so erratic that potentially you may have to oversize UPS just to deal with the erratic load profiles on there. High power computing, not so much of a problem because it's relatively stable, but definitely with AI, we could probably see 50% overrating required on a UPS just to deal with the load profiles that's being touted. So in that case, it then becomes very, very difficult because you end up with a lot of containerized pods dealing with a relatively small load.
Yeah, really interesting. I think something that we're going to see more and more of as AI expands. Pierre, I know you've been very, very patient with us when talking on this subject. Is there anything that you wanted to add on the modular solutions and maybe some of the benefits and limits that we're seeing across the market?
Well, I think, as they've mentioned, modular will be a long-term solution if done well. So basically, I think that all is about balancing so that the footprint, the UPS efficiency, its serviceability and maintainability, and basically that's where more of the progress needs to be made in the coming years. So, but there is a big pressure, a big demand from the market in terms of power need. So that will drive drive innovation for sure. So basically, I think I'm looking forward to the future on this and what we will be able to put together in terms of systems efficiency, because we'll be moving away from a product-only approach and be more and more about systems or subsystems efficiency level.
Yeah, that's a nice positive spin from the challenges that we're seeing. Now we're seeing innovation and movement forwards. Let's move on to looking ahead. Let's talk about what we are going to see versus what we're seeing currently. I'm going to pose this one to the both of you. I think it's quite a broad question, so I'm interested in where you'll take this. But what's actually new in the upcoming UPS? What's new for the market? Where does the industry need to go, and where are we moving towards? I don't know who wants to take that one first.
Well, maybe I don't think I will cover everything, but one thing's come to my mind when I think about what's new about UPS with the market evolution. We were talking about the Nordics and the requirement to support the grid. And basically, if you step back and look at the UPS as it was yesterday, which means a facility product, something you bought and use inside your facility, and it was only your concern, your need, and basically you could do whatever you wanted with it. And with these grid support requirements, it's becoming more and more a grid product, something that you share with others. So it brings a lot of benefits for the community. I think it helps also to reduce the bill. If you provide services, you get paid for that. But it also generates a lot of challenges, because what used to be a critical asset to protect and ensure uptime is now put at risk because it can be used by others at times where you don't always master or decide. So that's a real big challenge I see in the future. We talk a lot about grid support. I think we are just scratching the surface at the moment. Most of the large colocation data centers will simply, offset from the grid for a few minutes to help to stabilize. There is not that much grid stabilization through frequency or voltage done at the moment, but this is where we need to go with the increased production of renewables. That's something which will be really mandatory. So, but that will pose many, many challenges on the vendors like us and on our customers in terms of design, clearly.
Yeah, really, really interesting point. I know we talk a lot about being a good grid asset and what that actually means and for the data center industry and beyond. Can you just talk us through where the current market is with using UPS as grid support and what that looks like currently?
Yeah, I'll take that. At this precise moment, the main region requiring fast frequency response is the Nordics, and there are financial benefits from DNOs to supply fast frequency response as a facility on sites. What we're going to find though is that there will be specification migration. So where it's required in the Nordics at the moment, as Nordic colos head further south, which they are doing rapidly, we're going to start to see that we're going to have the same specification appearing in Germany and in Spain and in the UK as well. So although fast frequency response is mainly being driven by the Nordics at the moment, it will migrate further south. Because we live in a world where grid support is required.
Yeah, thank you. And it's interesting that you're saying that potentially this might be mandated, specifications might move. Again, a topic that we're talking more and more on here on the Critical Power channel. To you, David, to answer our previous question, is there anything new that you're seeing in the market? Any trends that you think this industry is going to follow that will impact UPS and how we use them?
Yeah, I mean, we're starting to talk about, back to the world of AI again, but we're starting to talk about the 1 megawatt rack as being a future challenge. At the moment, we're around 200 to 300 kilowatts per rack. As we move up to a 1 megawatt rack, though, that will obviously, it will be DC operated. So the traditional AC output UPS will probably not be required for that application, but it will be required for every other application. So, we might see hybrid sites now where we're going to have the mechanical system sitting on a traditional UPS system with an AC output, especially now as the mechanical loads are becoming as critical as the IT loads. And then we're also going to see a DC solution sitting powering the racks directly. So it's a bit like the Wild West at the moment. Nobody really knows what's going to happen over the next few years, but we know something's going to happen. So
what's the impact?
Yeah, the impact is that people just start looking, and we as manufacturer are starting to look at the different types of solutions that may be required for the future, i.e. a DC UPS, where we can support very high DC voltages and really, really high DC loads. Again, it's not just the UPS, it will be a requirement for all the, all the busbar solutions as well. It's going to be a complete rethink, potentially, of how UPSs and critical power solutions are employed within a data center. And it's going to be a complete sea change. There will be some increments. There will always be the Cold War of efficiencies, where people will get 0.1% more and then someone else will leapfrog and get something else. So there's always going to be that natural, evolution. But we're standing on the edge of a revolution. There's going to be some big changes. And again, we can only surmise what they'll be. There's going to be, direct chip cooling. That will be in conjunction with rear door cooling, all of which will require, that critical power support. So basically UPS, because the dynamics of AI means that we'll have to treat mechanical loads as IT loads. So yeah, it's we can only guess what the future is going to bring, but looking at all the indicators at the moment, split AC/DC solutions could well be, future innovation. Yeah.
I mean, just talking on kind of broader trends as well, and some of those changes we've seen, be amiss to not talk about product environmental declarations, how they're changing. We're seeing that end-to-end integration and movement for manufacturing. I know we talked about this earlier, but while we've got time, I think it's interesting to touch on how that change is going to impact customers and what that means for, as you say, CSR and footprint too.
Do you want to take that, Pierre?
Yeah, sure.
I
think when it comes to CSR, as you mentioned, the CSR, I mean the product environmental profile declaration, the core of it is transparency. So, which means that it requires a change in the way we design the product, because you can't design a product and then decide to make it greener once you have your prototype. It's too late. You really need to incorporate circular economy in the design of the product. So you come up with a solution, which means you need to rework your supply chain. So that's really long-term trends. We see them happening. It won't happen overnight. So I think most companies, and Legrand definitely, will keep continuing working on this for the next years. And again, that will require some major changes in terms of manufacturing, in terms of supply chain, and driven by a design. So our teams also need to rethink the way they design the product. So that's a lot of changes ahead. Then it's how we partner with our customers. So that what we do today, which is obvious, is really to be transparent and give the data to our customers so they can make their decision well informed and having all the data points, all the metrics regarding CSR for our very specific products. And basically, I think what we will have to do, because at the moment, what we call the PEP, so the product environment profile, are quite technical documents. I think some KPIs will emerge in the future years to ensure that we really, have a driver here, and we that every data center operator is really driving towards social responsibility, environmental responsibility effectively. So with a simple driver. So I know PUE now is outdated a bit, but it helped the industry to make huge progresses in terms of efficiency. It's not enough. We know that the water is a big concern at the moment. If we look at what's happened in Spain in terms of fluids, etc. So that's something we really need to look at. But so basically, I see future change here.
Thank you. Yeah, I won't ask you too much on PUE. I think that's a whole can of worms that maybe we could do an entire new episode on. So I'll leave it there. But I think, Pierre, you actually already answered one of the questions I had, which was, what makes Legrand unique? What is it about Legrand that's driving you forwards in this space?
Well, I think Dave mentioned the fact that we manufacture in Europe because it's, you can manufacture in Asia and sell in Europe, but at some point it will be conflicting your CSR objectives because everybody knows that transportation is a big driver for carbon emissions, for pollution in the oceans, etc. I'm not saying that transportation is bad. I'm not saying that we should stop buying things from Asia, from Americas, etc. But at some point, we need to put some rationale behind all of this. So I think what makes Legrand unique is this European footprint we have in terms of industry, manufacture, and the fact that we are, we really master so the systems and the subcomponents. So either within the group or with suppliers which also sit in Europe. So I think that's a big driver for us moving forward.
Thank you. And
yeah, I think just
yes, of course.
Sorry, just to add to that, as an example, our UPS supply chain sits within a 10-kilometer radius. So of where we actually assemble the UPS. So it's a very, very, very tight, very, very short, distances between factories, etc., which gives us the advantage of obviously reducing carbon footprint and the security of supply that we spoke about earlier.
Yeah, I mean that's a huge benefit. That really is quite an advantage. Just kind of looking to time, apologies, we are coming over. Before I get told off, I'd like to throw to both of you our final question. I'll throw out to both of you a final thought, key takeaway. If you can summarize today for our viewers, what would it be? Dave, let's start with you.
Yeah, from my point of view, it's efficiency. It's efficiency of the product, of the supply chain. This is really what we're talking about. The efficiencies that we're showing now on the product itself, and the efficiencies we're showing within the supply chain. are real benefits to the market. And that really is my takeaway is efficiencies.
Fantastic. Thanks. And Pierre?
Well, having my service hat, I would say it will be serviceability, of course, and maintainability of these. I also strongly believe that moving forward, we see the power demand increasing on the same footprint, which means that we will see a move from the medium voltage and the high power device are migrating closer or even inside the white space. So that will be also a big change in terms of how data center operator needs to design, because you cannot feed a 1 megawatt, a bunch of 1 megawatt racks with open channels that we use today to feed 200 or 300 kilowatt racks. You need to go to hyper busbar, which means that the place of the UPS will have to be challenged, as well as where they will sit in terms of location inside the data center. So many changes ahead.
Many changes ahead. Pierre, Dave, thank you so much for coming on and talking. I know we've only scratched the surface in 45 minutes. To those watching, please do reach out to the Legrand team. There's a lot of experience on this. I'm sure they're happy to answer your questions. Additionally, if you want to find out more, just look to the bottom of the screen and there'll be resources down below for you to look at as well. And thank you to Legrand for supporting us on putting this episode. Please do join us for the rest of this flagship broadcast where we'll be talking more on backup and generation. But that's all for today. Thank you and bye-bye.